Mastering EKS Fargate, a step-by-step guide to running serverless containers. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Running containers on AWS EKS Fargate provides a robust and scalable solution for deploying and managing applications without managing the underlying infrastructure. This podcast will walk you through the essential steps to set up and deploy Fargate Pods on AWS EKS. Introduction to running containers on AWS EKS Fargate. AWS EKS Fargate allows you to run Kubernetes pods on serverless infrastructure, eliminating the need to manage EC2 instances. This managed service automatically provisions and scales the required compute resources, simplifying container management while ensuring your applications are secure, scalable, and cost-effective. An overview of AWS EKS Fargate and its benefits. Fargate's serverless compute engine integrates with Amazon EKS, enabling you to deploy Kubernetes pods without worrying about the underlying infrastructure. Some of the key benefits include: no server management. AWS manages the infrastructure, freeing you to focus on your applications. Scalability. Fargate automatically scales based on the needs of your applications. Cost efficiency. You pay only for the compute resources your pods use, and there is no need to provision excess capacity. Enhanced security. Fargate provides isolation at the pod level, improving security. Setting up the Fargate pod execution IAM role. Before deploying Fargate pods, you must set up the IAM role that allows the Fargate service to manage and run your Kubernetes pods. Create the IAM role. Go to the IAM console in AWS. Create a new role with the Amazon X Fargate pod execution role managed policy attached. This policy grants permission to pull container images from Amazon ECR and send logs to Amazon CloudWatch. Trust policy configuration. Attach a trust policy to allow the xfargate.amazonoz.com service to assume the role. Version: October 17, 2012. Statement. Effect: allow. Principle: service: xfargate.amazonoz.com. Action: STS assume role. Establishing a namespace for Fargate pods. Namespaces are critical for organizing and managing Kubernetes resources. They allow you to logically separate different environments, teams, or applications within your EKS cluster. Create a namespace. Use the following kubectl command to create a namespace for your Fargate pods. Kubectl create namespace Fargate apps. Why namespaces are essential. Namespaces help prevent naming conflicts, allow resource allocation per environment, and enable better access control. Creating a Fargate profile for your cluster. The Fargate profile specifies which pods should run on Fargate and which should not. Configuring this correctly is essential to ensuring your pods are deployed on Fargate. Configure the Fargate profile. In the EKS console, navigate to your cluster and create a new Fargate profile. Specify the namespace, for example, Fargate apps, and any label selectors if required. For better security, define the subnets where Fargate should deploy your pods, typically private ones. Deploy the Fargate profile. Once configured, the Fargate profile will automatically launch pods that match the specified criteria on Fargate. Deploying pods to run on AWS Fargate. With your Fargate profile set up, you can now deploy your containers. Deploy containers using kubectl. Create a Kubernetes deployment manifest specifying the namespace, Fargate apps. Use the following command to deploy. Kubectl apply your deployment.yaml namespace Fargate apps. 2. Verify pod placement. Verify that the pods are running on Fargate using the following command. Kubectl get pods namespace Fargate apps wide. Deep dive into Fargate pod execution IAM role configuration. For advanced use cases, you may need to customize the IAM role for specific Fargate profiles or clusters. Customizing the IAM role. Modify the existing IAM role to include additional policies required by your application. For instance, you might need S3 access or DynamoDB permissions. Best practices. Always follow the principle of least privilege when customizing IAM roles to minimize security risks. Understanding Fargate profile selectors and subnet configuration. Fargate profiles use selectors to determine which pods should be deployed on Fargate. These selectors can be based on namespaces and labels. How selectors work. Selectors match pods based on the criteria you define. This ensures that only the intended pods are deployed on Fargate. Importance of specifying private subnets. Deploying in private subnets increases security by restricting direct internet access to your pods. Ensure that your private subnets have NAT gateways for outbound internet access. Conclusion. Running containers on AWS EKS Fargate offers a streamlined, scalable, and secure way to deploy your applications without managing infrastructure. Following this podcast, you can confidently set up and deploy Fargate Pods, optimizing your Kubernetes workloads on AWS. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.